I see the problem. It's you. I got it. Okay. Hopefully, that should have fixed the problem. Okay. Let's get back to it. Let's see. Question 4. Question 4. Paste. Okay. Question 4. Let's do it. Who are we up to? Darius just did that. Gabs. Gab,
Yes. Yes.
let's do question 4, please.
Question 4. All right. Let's see.
Have a look. Take your time. Tell me what you're thinking.
Put it into an equation here.
So, and what's your reason?
I don't know. I don't really know how to explain it. They're just represented that way. I gotta put them in like a equation here.
But hold on. Are you trying to say that these two are equal to each other? Is that what you mean by
Actually, they would be, right? Yeah.
what's your reason?
Um,
Unless you have a reason, you're not allowed to
gotta
say
think of
something.
this. Gotta think of this.
Got to think. Think. And if anyone can help him out, if they know what the reason is directly.
Is it isosceles?
No, it can't be isosceles because I haven't given you that they're equal to each other. Equal. These means parallel. Arrows mean parallel. Lines mean equal.
I'm actually not quite sure.
Then we can't just say directly these two are equal to each other. So you got to forget about that. Then think of another like I said to Grace before. We've got 3 letters: Z, F, and a C.
Yeah.
Which one do you think will work well for here out of all 3? Now, it doesn't mean it's going to be directly there. It's just which one can you use at least? Can you use a Z? Let's cancel some stuff. No, so that's definitely wrong.
Yeah.
Can you use a C?
I guess so, yeah.
Yes, you can. We could use it like this, or you could even use it like this.
Yeah.
So let's do that then.
Yeah.
So this angle ADC equals 180 minus open bracket 2y plus 10. What's your reason?
Co-interior.
Co-interior. Angles, and then which two are parallel? Which 2 did we use that are parallel?
Which 2?
It's 2 lines.
I think AB and DC.
And DC. Good. So then we found this angle. Just assume it's whatever this is when it's simplified. 180 take away 2y, take away 10, which is 170 take away 2y. Great. And now what? Now what do you know about these 2?
Oh, they're both equal to 180, right?
Yeah, they both add up. So angle ADC plus BCD equals 180. What's your reason?
Co-interior.
Co-interior. Angles. Again, which 2 did you use there?
AD and BC, right?
That's right. That's why we've got to write it, because we're not sure if you guys know which ones you're dealing with. All right, easy. 170 take away 2y plus 5y take away 56 equals 180 degrees. 170 take away 56, 114 plus 3y. Then we're going to subtract. So 3y gives you 66. And then, of course, y equals?
Y equals 66. Oh, wait. Hold on. So 66 divided by minus 3, right? Oh,
No,
divided by
y,
3.
just 3. Yeah.
Yeah, yeah. Sorry
So
about that.
y
Yeah.
equals to
So just
22.
22.
And that's it.
Interesting. Yeah.
Interesting. Now, just for you guys, for the ones that want to learn it, these two actually are equal to each other. And the reason is something we haven't spoken about. Opposite sides, opposite angles in a parallelogram are equal. So opposite angles in a parallelogram are actually equal. So these two will be equal to each other, just like these two will be equal to each other. Good job.
Yeah.
But it's not something we've spoken about, so I didn't think anyone would know it. But if you have heard of that rule before, great. You could have used that. I wouldn't have minded that. Question 5. Let's see. Question 5. Let's go for Samuel. Question 5. Take your time. Have a look at it first. We want to find x and a y. You got all these. This is a rhombus, obviously, at the moment as well, just so you know. All right. What are you thinking? Let's wait. Let's get something clear, just to make sure that everyone's on the same page. Can you say that AB is parallel to DC?
Yeah,
What's your reason?
isn't it because they're equal?
But isn't this okay? You said they're equal. Isn't this, which is 5 centimeters, doesn't this also equal to this 5 centimeters? Are these two parallel?
Yeah.
These two are parallel.
Oh wait, no, sorry, no.
How can you say these two are parallel? That one's going up this way, that one's going this way. So just because they're equal, does that mean they're parallel?
No.
In a square, everything's equal, right? Let's just say they're all 4 centimeters. Does that mean this is parallel to this?
No.
No way. So can you, just because they're equal, can you say they're parallel?
No.
So I'll go back. Do you have a reason for why AB would be parallel to DC? Doesn't look like it. So can AB be parallel to DC? Just because it looks like it's parallel, that's not a good enough reason. So unless there is arrows to tell you that they are parallel, you cannot assume they are parallel. So forget about your parallel lines. It's not going to be done that way. Now you got to start thinking of a different way. So go. What do you see?
I'm just still analyzing it.
Yes, that's not no problem. We're not rushing you. Take your time. Can you tell me what you're looking at and what you're thinking? So I can help you a little bit. What do you see? Hey? Nothing?
Oh, sorry. I accidentally muted myself.
Okay, that's fine.
Does a rhombus, or does all the angles in a rhombus have to equal 360?
Yes.
Okay. I'm just thinking that like each corner of the rhombus
You
has
can
something.
tell me the letters.
Like
So, like letter what or what angle?
a angle. I feel like that. Like angle ABC has to equal like the total like angle has to equal 90.
You think so? So does that look 90 degrees to you?
Yeah, that's what I was thinking. It doesn't look 90 degrees.
And if you're going to say it's 90 degrees, you're specifically assuming now it becomes a what?
Square.
Yeah, you're assuming it's going to become a square.
Yeah.
You're assuming all this, which is not allowed in geometry. Just like I said, it's not allowed for you to assume it's parallel. So good try. Nope. Anything else?
Not really.
Nothing. Okay. Let's give it to someone else. So let's see who's next. You tried at least, so thanks. Pat, you've got to put yourself on mute unless you need to talk. Shatu, let's try. You try question 5.
All right.
What are you thinking now? So we said it's not parallel. We said there's no. He said, "Oh, divided by 4, so they're equal." I said, "No, that's not right." What do you see? What can you do differently?
I don't really know, to be honest.
Let's highlight something for you. Look at that.
Do you have to make it equal?
Yes. So what would you say is CBO?
30.
Right. There we go. We're getting somewhere. And then what? Now it should be easy.
We add it.
What do you mean by we add it?
Like, do we add 30 and 30?
Yeah, that becomes 60.
Yeah.
And then we want to find y. How are you going to find y now?
Oh, wait. Do you divide it with...
What does it mean? With these two sides equal to each other.
will that be 30 as well?
No, you're missing it. So if these two are parallel, if these two sides are equal, the base angles are equal.
Mm-hmm.
If the base angles are equal, then we know that it would be 180, take away 60 degrees, which is 120.
Yeah.
And then you're going to divide it by 2. So that means y is equal to 60 degrees.
Okay.
And if y is 60 degrees, what can you tell straight away about x now? That's 30, that's 60. What should x be?
60?
No.
30?
No. Why are you just taking guesses for? That's 30. That's 60. You got to find this angle.
Oh.
What would you do?
Do you take away? Do you do 180 minus 30?
180 minus 30 only? And that gives you 150. So you're going to say x is 150?
I don't think that's right.
Take away 60. What happened to your other angle? Equals 90 degrees.
Okay. I get it.
So, yeah, I know, but because you guys, you are one of the students that hasn't sent me the homework. And that's why you're going to struggle with this. If you don't complete the work, it's going to get a little bit hard for you to be able to progress. So be careful. Question 6. Try to get on top of the work. Question 6. Paste. All right. Samuel, let's go again. I'm sure, Samuel, you saw when we did that, when I drew the yellow triangle there, you realized that was pretty straightforward from there onwards.
Yeah.
So you got to start thinking like that, you know. I saw this. All right, back to parallel. Again, just take your time. Well, this one's a bit easy. That's 5.5. What does x equal to?
5.5.
Yeah, that's easy. And then obviously, what does y equal to?
4.
Diagonals bisect in a parallelogram. So if I've got any two diagonals, they actually bisect each other on a parallelogram. So they'll always be equal to each other. They cut in half. Bisect, similar to dissect. That just means, diagonals bisect. Bi cuts into two, cuts in half. Nice and simple that was for you, actually, Samuel. You're lucky. I was trying to give you a hard one. Question 7. Question 7. Pat, do you want to try question 7?
I was still trying to wrap my head around it. I'm not too sure.
Not yet. Well, do you know what the angles add up to in a quadrilateral?
It's not 360 degrees.
Yep, that's right.
Yeah, okay.
So how
It'd
would
just
you
be
find x?
all of them plus together and then
Yep.
minus 360.
That's it. So 360 minus all of them plus together.
Yeah.
Good work. And what's your reason? Angle sum of a quadrilateral. Very easy. The answer to this would be 164 to 89. So 360, take away 289. Should give you about 60, 70, 71, 81, 71. If my math is not wrong, I'm sure one of you guys would double check it. Around 71 degrees. Good work. Last one, I think it is question 8. Let's have a read of it again. Firstly, together, and then I'll choose someone to just have a read. Again, please have a look. There's no parallel sides. So stop thinking of your parallel lines. Start thinking of just triangles and maybe straight lines, and obviously your isosceles triangles. All right. Anyone have an idea of how to start this?
I think
Yep.
y is
Y.
65.
And your reason?
N to O is it's okay if you just look at it as a triangle.
Right.
It's a right angle triangle, and then
So
you
you're
have
saying
that-
this is a right angle right there?
yeah, so 90, and then all of it has to equal to 180.
Yes.
So- Oh, sorry, it wouldn't be 65. It would be
You realize. Okay, I'm going to stop for 1 second. Can someone tell me where he's going wrong with that? The answer's probably right, just so you know. But what is something that is wrong that he said.
That's not always going to be a right angle triangle.
Yeah.
Right
The fact that you've assumed it's a right angle. Again, my only question to you is, we're going to write it. So we're going to write, let's say, angle NRO is equal to 90 degrees. And you're going to say, what's your reason? You're going to say, because it looks like it. It looks like it. Not really. We can't give that to you, right? You know that. So unless you have a reason in geometry, you can't exactly use it, unfortunately. So, like I said, your answer might be right. Your answer might be right. It's just the way you approached it was actually incorrect. Another day, another question, maybe exactly the same. I might actually give you information and say that's a right angle, or I do put a right angle there, then you can continue and everything you said was right. So, good shot. This doesn't work in this case just yet. Anybody else see anything?
Angle
Well, yeah.
QR would equal to 65 degrees.
There you go. 65. Might be helpful, might not be, who knows. But right now, we put it in there. Cool. What else?
And then angle QNO would equal 180 minus 65 minus 65.
I like it. So this angle is equal to 65, take away 65. I mean, 65 plus 65, which is 130. And then 180, take away 130, which is 50. So this angle in here is 50 degrees. What does that mean about y now?
50 divided by 2, which is 25.
25 degrees, because y has to be halfway of these two. That cuts it in half. Good. Okay. So now we've got y is 25, because diagonals bisect. That's 25. That's good.
And then 25 plus 65
Is
and then
90.
take away 180.
And then that's 90 degrees there. Good.
And
So
then
now we proved, can you see how now we prove that that's 90? That's perfect. And then z equals to?
180 minus 90, which is 90.
That's a straight angle. So 180 take away 90, which is also 90 degrees. Good. So now we've got this one 90 and
90 plus 40
right.
equals 130, and then 180 minus 130.
180 minus 130 is 50 degrees in there, and therefore x is also 150 because obviously this is symmetrical. So 40 and 40, this is 90, this is 90, but same thing, x is equals 50. All right, let's write it all down properly now. So where did we start from? We started from angle NQR or NQO, it doesn't matter which one. NQ, we'll just do NQR, equals 65 degrees. What was your reason that we said? It was isosceles triangle. Where is the isosceles? The big triangle right there. Isosceles triangles. NQO. Maybe we'll just write isosceles triangle NQO. Base angles are equal. Base angles equal in isosceles triangle NQO. A little bit more fancy, but that's fine. And then we found that was 65. We then said angle QNO. Angle QNO equals 180. Take away 65 plus 65 to find this big angle up here. What was the reason there? Angle sum of triangle, which gives me 50 degrees. Then we found angle ONR, which equals 25 degrees. Reason, diagonals bisect angles which means cuts the angles in half as well. In a parallelogram, in a well, it's not really a parallelogram, in a quadrilateral, So we got that's 25. And then we went and found angle NRO. That becomes 90 degrees. What was our reason there? Well, now that we know the top one is 25, 25 plus 65 is 90. Now I use the smaller triangle, and we found that's equal to 90 angle sum of a triangle. Once we found that angle is 90 degrees, we found angle ORP. Angle ORP equals also 90 degrees. That's an angle sum of a straight line. Angle sum of straight line. Now we found Z. Once we have found Z, you can say that angle ROP equals 50 degrees, because now that you know that that Z is 90, this bottom one is 40. Again, a triangle down here, ORP. Subtract 90 and 40, you'll get 50 degrees. That's angle sum of a triangle again. And that's great. You found ROP, but then you can say RQP, the X value. Angle RQP is also equal to 50 degrees. What's your reason? Angle, there's a few ways of saying it. You could have said the two triangles are congruent or are equal. I'm going to say, yeah, I'm going to just say for now to not overcomplicate it. ORP, triangle, ORP is the same as triangle RQP. For those who understand congruency, you could have used congruency there. So therefore the triangles are equal. Otherwise congruency just means the triangles are equal anyway. So either one is fine. Whoa, right? That was intense. See, it was probably a lot easier to find the X, Y, and Z. It's a lot harder to actually write them out. Good news, this is out of the syllabus in year 11 and year 12. So they've taken this out because it's too irrelevant for future years now. Bad news, it's still there up to year 10. So you still need to know it for this year and next year and so on. But it's not actually tested any longer past that. All right. All right, let's finish this off. I think we're up to a test. We'll do some of these test questions. There's only 5. These are bearings. Yep, there's only about 5 questions. Let's do these 5. And then I'll get you guys doing a bit of revision, and then we'll see exactly who's still struggling, and then we'll decide on our next topic for next week. Okay. Question 1 here. Let's see who hasn't had a go yet. These guys are fine. Jamal, question 1I.
Yeah.
Let's do it. Question 1I. Again, it's up to you. We just did one very similar to this. So you either know the rule. Do you know why these two are equal to each other?
They're part
Opposite.
of this. I'm still
opposite angles in
angles.
a
Parallelogram.
are equal. That's it. We're going to use that one. So if 5y minus 10 equals 7y minus 60,
Minus 60.
and then reason opposite angles in a parallelogram equal. That's just to make things a lot faster for you guys. Cool. All right, go. What do you want me to do? When you're
So
solving this?
bring the 7y over to the left side and then the minus 10 over to the right side.
Can I tell you 5 take away 7 is a negative? Try to always keep your pronumeral positive if you can.
Okay, so bring
Bring
the
this guy
5
over.
and then the
What you
6
said
minus
wasn't
60.
wrong. It's just less room for
Yeah.
error. All right. 7y take away 5y
2y
minus 10 plus 60,
50,
50. And then see how there's no negatives?
Yeah.
Just looks neater.
and then
Y
divide
equals
by 2. 25.
done. Good work. Again, anyone have any questions there? All right. Jamie and Jenna. I know Jamie, you said your mic isn't working today. Jenna, next one. It's going to be a hard one, Jenna. So we'll take our time. Just have a look at it all first. This angle in here is 3x take away 40. This angle in here is x plus 10. And we know this is x.
Yeah.
We want to find x. Okay. And you know this is a triangle. I'll just show you everything that I can see. That's a triangle. I also can see a straight line there.
Yeah.
All right. Up to you now. Tell me. So forget parallel lines.
Yeah.
Just think of maybe the shape that I just said and the angle I was just saying, and just say stuff, and then we'll see what happens. Seriously, there's no wrong method. Just so you know, there's no wrong method other than if you had decided to go for like alternate angles or corresponding or something like that. But if you had said like anything else to do with a triangle or a straight line, you actually will realize it works well.
Okay.
Okay, so don't hesitate. Just tell me again. Go. What do you got?
I was thinking, I don't think it's right, but I'm just gonna say it. 180, minus x plus 10, plus 3x minus 40.
That is this angle. Do we agree with that?
Yeah.
Is that where you're thinking?
Yeah.
I think you're correct.
Okay.
So yeah. See how before you said it, you said I think it's wrong.
I know.
But you don't know if it's wrong.
I don't understand this topic. I hate this topic.
Well,
it annoys me.
Clearly, you understand it.
I don't like it.
Why did you subtract them? Because to you, your logic is this. You're like, all right, I've got a missing angle. I've got something here which is 60 degrees. I've got something here which is, let's say, 30 degrees. Well, to find the third angle of any triangle, I would add these two. So 60, for example, plus 30, whatever it is. It doesn't have to even be a number, right? It could have been a square. You could have had a triangle plus a circle. Gives you a triangle plus a circle. And then you would have said, to find the third angle, you got to do 180 take away 90, which gives you, in this case, gives you 90. But if it was a triangle plus a circle, you would say it's 180 take away a triangle plus a circle, which gives us 180 take away triangle take away circle. And that's it. That would be the answer.
Okay.
The problem is a lot of students are obviously used to this one. They're used to numbers. And they think that they've got to somehow do things differently when it becomes like this. But it's not. It's exactly the same, isn't it?
Mm-hmm.
It's just instead of it being 90, it's some fun shapes. All right. All good. You've done it right. I know what you're feeling. We spoke about this, but I think you're good. You're on the right track. So I'm going to continue now. You said 180 take away x plus 10 and then take away 3x, take away 40. So in other words, 180 take away x plus 10. I'm just going to do it plus 3x take away 40. So I would have added up the two angles and then subtracted. You okay with that?
Yeah.
Then 180 minus, let's simplify the bracket first before we expand. So what happens when you simplify this?
4x.
Yep.
Yeah.
And then these two.
Negative 30. Oh, minus 30, sorry.
That's fine. Either one doesn't really matter. Equals. Beautiful. And then expand your brackets now. So 180 take away
150. Oh, sorry.
4x. Oh, no. First you got to write minus. So negative 1 times 4x, right? And then negative 1
right, okay.
times negative 30. Yep. So minus 4x and then?
I'm stuck.
What do you usually do when you expand? Like something like this. What's the answer to this when you expand this?
AB plus AC.
Isn't it funny that you know that? All right, one more time. Then
Isn't
you've got
it
negative.
180?
No. Forget the 180. 180 is
No.
not even attached, is it? It's negative 1. So wait, it's like this.
Oh, okay. Okay, yeah.
It's like this. The 180 is like, don't worry about that. That's got nothing to do with you right now. Forget it. So negative 1 times 4x is what?
4x. Oh, negative 4x.
And then negative 1 times.
It's just positive 30.
Yeah, there we go.
Oh my god.
All right, plus 30. Beautiful. And then that's when you start bringing the 180 in. 180 plus 30 is 210. Take away 4x. Okay, let's pause there. Anyone have any questions about any lines that we've done? Again, I think I have to say it one more time. See how it's more equations and algebra based. So once you master the algebra, this shouldn't be too bad. I don't know why you got stuck there, Jenna. I think you were okay with that. You're probably just stressing yourself out there. But that was
Probably.
easy. Oh, good. 210, take away 4x. Anyone have any questions? All right. So you found that. That's great. Now what?
180 minus
Yes.
bracket 210 minus 4x bracket.
What must that equal to? So if you're going to do 180,
Oh, right.
if you're
Okay.
going to do 180 take away this angle, what would you write it equals to? Think about it. If this was 60 degrees, what are you doing when you do 180 take away 60? What did you just find? What angle would you have found if you're going to do 180 take away 60? If this was 60 and you said do 180 take away 60, where did you just? All right, well, why did you even say 180 take away?
Because it's a straight line.
Yeah, so
And
if that's 60, if you're going to do 180 take away 60, aren't you finding this part
Yeah.
straight line? So when you're saying do 180 take away 210 take away 4x, what are you going to say it equals to?
36. Oh, x.
X.
Yeah.
Isn't 180 take away this angle equal to this angle up here?
Yeah.
I think, you know, it would be easier, because that seems like it's confusing. What do you know about these two angles?
That they have to add up to 180.
So then do it that way, because that
Okay.
seems it's easier. So then let's do that. 210 take away 4x plus x has to equal to 180.
180. Yeah.
And then, of course, negative 4x plus x is negative 3x. And then you would subtract your 210 minus 30. And therefore x equals to?
10.
Yeah. There was almost no geometry there. Right. Got a lot of algebra. Do you want to do that one again from the beginning? Because that's a very common question. Let me just see if there's another one.
Yeah.
Just so you can get good at that. No, don't have one similar here. No, that's fine. Do you want to do the same one again? Or you feel like you know it too much right now?
Even
Or
if
you don't
it's
know it?
a different question, I won't mind. I think.
Yeah. Yeah, let's do that. Hold on. Okay. I'm just going to use the diagram of this. I'll write the numbers. Similar thinking. Don't overkill it. All right, let's have a look. This is isosceles. So let's say that's x. From that, you'll be able to get that and that. Then I'll give you this is 3x minus 40, this angle. And okay, and that's all I need to give. All right, go. Have a look again and tell me what you see and what you want me to do.
Because I have the idea in my head that with the triangle thing, and then each sort of.
Yeah, but look, so
yeah.
you have to use the facts that they're given as well, right? So I've
Yeah.
given you that's isosceles, so you've got to use that straight away. So how are you going to use that? If that's x, what does ACB equal to?
180?
Nope.
No.
Angle ACB, this one here.
Oh, okay.
Tilt your head to the left and you should see it looking like this.
Yeah.
If this is x, what would you say this one is?
X.
Why?
Because it's an isosceles and both of the bottom, are the same.
Angles must equal to, base angles are equal. Correct, so that's x, there you go. Now what? Now you've got two sides of a triangle. So what can you say about this angle here?
180 minus 2x.
Angle BAC is equal to 180 minus x plus x, which is 2x. So now you've got this angle in here as this. Good. You're missing a third angle, angle DAC. What does angle DAC equal to? No, you haven't used one piece of information that's also given. What's the other piece of information that's given that we haven't used just yet?
Oh,
you might have seen that.
parallel.
Yeah, the fact that these are parallel.
Yep.
And do you think you got angle DAC out? Do you know what it would be? Keep looking at it. Keep looking at your parallel. Think of the letters.
No.
Keep looking. Don't say no. Tilt your head to the left.
Oh, okay. I thought about that before and I didn't say anything, but yeah, okay.
Which is what? What's it called?
Uh, it's an alternate angle.
Alternate X degrees. Alternate angles. I know that's the problem. I know everyone says that as well. They go, I thought that. And it's true. I'm not saying you didn't think it. The problem is you guys hesitate writing it down. So I'm trying to say, please, just write. It's fine. You'll be more correct. That's what I was trying to say last week as well. All right. Well, we're up to this stage. Now, what do you know about the three angles, Jenna?
That they all have to add up to 180 because it's a straight line.
That's it. 3x take away 40 plus x plus 180 take away 2x equals 180. Again, simplify this left-hand side for me. Tell me what your answer is when it's simplified. Let's have a look at it. Take your time. Let me know what to write.
2x
Yep.
equals 40.
Yeah, fair enough. I'll give that to you. So you already took out the 180 and 180, and then you plus the 40. Good.
Yeah.
X equals?
20.
Done. Okay, and just recap that. Look where we started. We started off at the X. I said there's a point, there has to be a reason why they gave you this line and then these arrows. If you don't use them, obviously you won't be getting it out.
Okay.
And the fact that they gave you these lines means they're isosceles, so start using it, x, you'll get this angle. Then from there, you'll hopefully should see your alternate angles. Then that's x, and then that's your straight line. You know these three angles must add up to each other to give you 180, and then it's just a simple equation. All right. Good work, Jenna. Let's go triple I. I think Liam, you did this one last week. Let's see if you still remember what to do.
Okay.
Any ideas?
You draw a line through FGH.
Yeah, you got to draw a straight line through FGH so that it's parallel to AB and CD. And once you've done that, you've got a lot of ways of doing it. You could have done it through co-interior. You could do it through alternate, which I think is the faster way. So your working out looks like this. Construct or draw line. You don't have to write construct. Construct, let's call this KL. Construct line KL through G parallel to A, B, and CD. If reasons were required. Usually with these, at your year, we don't really write reasons. We just go find X. But I just want to show you the other way. Then you can get FGL, angle FGL equals, what does it equal, Liam?
109.
109, reason?
Alternate angle.
Alternate angles, AB, parallel, KL. Angle HGL equals 130 degrees. Same reason. Also alternate. CD parallel KL, or DC parallel KL. And now what?
360 minus 109 minus 130 equals X.
And reason?
Was it revolution?
Yeah. Revolution angles equal to 360. Easy stuff. What's the answer to this? 249. No, sorry, 239. 121. Again, if I haven't done it wrong in my head, something like that. All right. Last two. Okay. Let's see. Who should we try? Grace, let's try this one together. Don't worry, we'll do it together. Grace, what can I do with the isosceles sides? How can I use that for this question? Grace, you there? No, she's left. Okay. Let's try Gabriel, let's do this one.
Yes. All right. This one looks pretty easy.
Yep.
Isn't like a isosceles, so
Yep.
180 minus 62, and that's divided by 2.
What do you get?
59.
59. So that becomes 59. That becomes 59.
And it's 180 minus 59, so it's just x equals 121.
Nice and easy. Good job. And again, your reasons here would have been isosceles, base angles in isosceles triangles equal. This one is just a straight angle sum of a straight line, or just write straight angle equals 180. Easy.
Yep.
Good work. Lucky last, V. Whoever wants to finish it off. What are we going to do for this one? What do we remember? The angle sum of the polygons of the outsides add up to of any polygon.
Isn't it? Yeah,
360. So how do we use that for this question?
360 divided by 5.
360 divided by 5. So then you can work out each of your exterior angles. What's that? 72? No. 360 divided by 5. It is 72, isn't it?
I'm pretty sure it is.
Yeah, I think it is as well.
And then 72 equals 2x plus 8.
Yeah. 2x equals 66. No, what? No, 64. 64. And then obviously x equals 32. That was an easy one. You just needed to know that extra case or extra knowledge there. All right. I'm pretty happy with that. This is what we're going to do.